Okay, Math 8 students, we are starting lesson 11.2, angle theorems for triangles. Our essential question is, what can you conclude about the measures of the angles of a triangle? So this is our key information here. This is what we're really looking at. By the end of this lesson, we want to be able to answer that essential question. So moving right into Explore Activity 1, sum of the angle measurements in a triangle. So sum again is adding angle measurements and triangles. There is a special relationship between the measurements of the interior angles of a triangle. So first of all, interior angles of a triangle are all of those angles on the inside. So these are all our interior angles of a triangle. So what it wants us to do is it wants you to kind of go through a little activity here, but it also gave you an example of this activity here on this side of the page. So we're just going to use this as our example. It wanted us to draw a triangle and cut it out. Label the angles A, B, and C. So here's our triangle. Cut it out. Angle A, angle B, angle C. We're going to tear off each corner of the triangle. Each corner includes the vertex of one angle of the triangle. So the vertex being these parts here. So we tear off all three corners. Okay? And then we're going to arrange the vertices of the triangle around a point so that none of your corners overlap and there are no gaps between them. So this is our point. And then these are our three pieces that were tore from this triangle. And so what do you notice about how the angles fit together around the point? Well, they all form along this line here. And we learned about this yesterday and the day before. We've been talking about this with our angles. These would all be supplementary angles, right? We can also, I'm going to give you a new vocab word. This is called a straight angle. This line right here is called a straight angle. So what do you notice about how the angles fit together? So we could say all angles are supplementary. Or we could say all angles fit together to form a straight angle. Okay, well, what is the measurement of a straight angle? Well, this is good to know, right? A straight angle is 180 degrees. And we talked about this a little bit, that any two or more angles that lie on one side of a line combine to be supplementary. They combine to be 180 degrees. So, describe the relationship among the measurements of the angles of triangle A, B, C. The sum of the measures is 180, right? So that's kind of just reinforcing what we talked about earlier. And then we'll just put in parentheses here, supplementary angles. So this is all summarizing to this theorem right here. The triangle sum theorem states that for triangle A, B, C, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So the sum of all angles of a triangle should be 180 degrees. So we can solve for missing angles when we know that. So let's go ahead and take a look at the reflect question now. Justify reasoning. Can a triangle have two right angles? Explain. So remember that a right angle is 90 degrees. If you have a triangle that has two 90-degree angles, you already have a sum of 180 degrees. Therefore, your third angle would have to be 0 degrees, right? Which doesn't make sense, right? You can't have a triangle that has 90, 90, 0, otherwise you don't have that third angle. So, you cannot have, no, the sum of the measure of the two angles is too big, right? the sum of the angle of the two right angles is 180. Therefore, that means the measurement of the third angle would be 0, which is impossible. Which means of the third angle be 0 degrees, which is impossible. Okay, you can't have an angle that's 0 degrees. You can't have two right angles in a triangle. So, second reflect question, analyze relationships. Describe the relationship between two acute angles in the right triangle. Explain your reasoning. So, if you have two acute angles in a triangle, that would be these two, right? We can determine that they are complementary, right? And so if you remember, complementary angles are angles that you add together to equal 90. So they are complementary. Which means they equal 90. Their sum equals 90 when combined. And that means that the third angle would be a 90-degree angle, right? Because that's what's left. So you would end up with a right triangle, which makes sense, right? Because right triangles has a 90-degree angle, right? So that would be our right triangle. That's 90 degrees, which means these two would have to be equal 90 degrees, their sum. Right? So that's kind of the relationship there. So they would be complementary because a right triangle, oops, let's put because. Has an angle that equals 90 degrees, right? And then all triangles equal 180. So 180 minus the 90-degree angle equals 90. So those other two angles would have to be a sum, would have to be complementary, and their sum would have to equal 90. They don't have to be the same. They just have to equal 90. They just have to be complementary. Okay, so let's go ahead and move to the next Explore activity, which is Explore Activity 2, Justifying the Triangle Sum Theorem. So you can use your knowledge of parallel lines intersected by a transversal to informally justify the triangle sum theorem. Follow the steps to informally prove the triangle sum theorem. You should draw each step on your own paper. The figure below has been provided for you to check your work. So on your own paper, maybe over to the side, you can be drawing this. We're going to use, what I'm going to do is use this example for your notes here. First thing we need to do is draw a triangle and label the angles as angle 1, angle 2, and angle 3, as shown. Draw a line through the base of the triangle. So that would be this line right here. Drew an angle through the base. Okay? The parallel postulate states that through a point not on line L, do we have line L? There's exactly one line parallel to line L. Draw line B parallel to line A through the vertex of the opposite the base of the triangle. Okay, so what that means is that you've got a line here. You're going to draw a parallel line through the vertex of the vertex that is opposite the base. Okay, so we're going to draw a parallel line through the vertex. That's this one that is opposite the base. So we've got two parallel lines here. Then we're going to extend each of the non-base sides of the triangle to form a transversal S and transversal T. So they extended them here, right? And they labeled that transversal T. They extended this one and labeled it transversal S. Again, we still have these parallel lines here. One that runs through this vertex, and this parallel line here that is formed from the base of the triangle. And then we still have our angles, angle 1, angle 2, angle 3. Okay? Now label the angles formed by line B and the transversal as angle 4 and angle 5. So here we go, angle 4 and angle 5. Because angle 4 and blank are alternate interior angles, they are blank. So angle 4, which is right here, and an alternate, so this is our transversal, an alternate interior, so inside our parallel lines, opposite side of the transversal, angle would be 2. So angle 2, because they are alternate interior angles, they are congruent. So this is just reinforcing some of those vocabulary terms that we were talking about earlier in this module. So here's our transversal, here's our parallel lines. These would be our opposite interior angles, our alternate interior angles. And now we're going to label angle 4 with the number of the angle to which it is congruent. So that would be angle 2. So angle 4 and angle 2 are congruent. Now we're going to do the same thing with angle 5. Because angle 5 and blank are alternate interior angles, so I'm going to use a different color. We've got angle 5 here, and it's alternate, so the one that is across this transversal, right here, but inside the parallel lines, is 3. So angle 5 and angle 3 are alternate interior angles, and because we've got parallel lines cut by a transversal, these are also congruent. Okay, so far so good. Label angle 5 with the number of the angle to which it is congruent. So that would be angle 3. Okay, so now we're going to go ahead and move down to H. So I'm going to scroll this up a little bit. And we're going to, the 3 angles that lie along line B at the vertex of the triangle are 1, 4, and 5. Okay, so we got angle 1, angle 4, angle 5. Notice that these 3 angles lie along a straight line. So the measure of angle 1, the measure of angle 2, and the measure of angle 5 equal, well, what do we know about angles that lie along a straight line? They are all supplementary, which means they all equal 180 degrees, right? Because this is our line, these are our angles. All of these 3 angles combined would give us a straight angle and equal 180 degrees. Okay. Because angle 2 and angle 4 are congruent, and angles 3 and angle 5 are congruent, you can substitute measure of angle 2 and measure of angle 4 and measure of angle 3 for measure of angle 5 in the equation above, right? So it's saying that you can interchange these 2 measurements because they would be the same, and you can interchange these 2 measurements because they would be the same, right? We know alternate interior angles are congruent on parallel lines cut by a transversal, right? So we should know that, so these 2 measurements should be the same and therefore interchangeable. So the measure of angle 1, the measure of angle 2, and the measure of angle 3, 1, 2, 3, also equal 180 degrees. And we know that to be true, 1, because they're interchangeable with these 2, and all of these are 180, but also because the sum of all the angles of a triangle equal 180 degrees. This shows that the sum of the angle measures in a triangle is always, we just said it, 180 degrees. We've got a reflect question. I put it up over here because it's on the next page, but I like to be able to see what they're talking about. So, analyze the relationship. How can you use the fact that the measure of angle 4, which I've got here, plus the measure of angle 1, plus the measure of angle 5 equal 180, to show that the measure of angle 1, 2, and 3 also equal 180? Well, if the measure of angle 2 is equal to the measure, oops, did that backwards, is equal to the measure, did it again, measure of angle 4, and the measure, oh, I did it again, measure of angle 3 is equal to the measure of angle 5. Substituting those angles in an equation would give you the same result, which is 180. Okay, and we just kind of proved that by the activity a little bit earlier. All right, so the last thing that we're going to do in this little video clip is the example 1, which is finding missing angle measurements in a triangle. So we're going to just look at this super quick because we just proved that the sum of all of the angles of a triangle should be 180 degrees, right? We know this. And so if we are given 2 angles of a triangle, then we can determine the third by subtracting the sum of these measures from 180, right? So let's go ahead, and that's what this example is showing here. It says we have 155, so 100 plus 55 equals 155, and that measure plus the missing one would equal 180, right? So what they did is they did inverse operations. They subtracted 155 from 180, and they got the measure of angle E, which is 25 degrees. So that missing angle is 25 degrees. And you can always double check that by just adding these all up, and they should equal 180. Okay, so let's do these your turn here and find our missing angle. So we are looking for the measure of angle K in this first one, number 4. We have the measure of angle J and the measure of angle L. So I'm going to write this out a little bit long-handed, but most of you will be able to just kind of power through this because you know what you need to do. So I'm just going to reinforce that rule that the measure of angle K, oh, I did it backwards again. Oh my gosh, I am on a roll here. Measure of angle K plus the measure of angle J plus the measure of angle L equal 180, right? Well, I have J, I have L, so I'm going to sub those in. So 71 degrees plus 56 degrees plus the measure of angle K equals 180. So I'm just going to combine what I know now, right? And so 71 plus 56, 6 plus 1 is 7, 5 plus 7 is 127, right? So I've got the measure of angle K plus 127 equals 180 degrees. I'm going to subtract 127 from 180 to find my missing angle measure. And so my measure of angle K should equal, let's borrow 53 degrees. So the measure of angle K is 53 degrees. And I can double check that by just plugging that back in and making sure that the sum of all 3 of these angles is 180. Okay, so I'm not going to do all this longhand for this next one. I'm just going to take what I know and do it a little bit quicker, right? So I know that all 3 of these should be 180, the sum. So I've got 29 plus 61. 29 plus 61 equals 0, 7, 8, 9, 90. Now I've got 180 is my total, right? Minus the angles that I know, which is 90, and that equals 90 degrees. So that means this missing angle is 90 degrees. That also means that this is a right triangle, right? If I have an angle measure that is 90 degrees, I have a right triangle. So my measure of angle R is 90 degrees. Okay, I'm going to take a little pause here, and then I will continue the next Explore activity and example on another video, on the following video.